So today we're going to talk about area. And when we are talking about area, we are going to end up adding up a lot of numbers. And so the start of this section just is a little review on sigma notation and how it works. So I have an example here for you to read through. Your formula is 2m. The bottom number is 1. The top number is 6. So you plug in 1 into the formula. Then increase by 1, so plug in 2, 3, 4, 5, plug in 6. Once you've plugged in the top number, you would add all these numbers up and you get 42. So I put 3 examples here for us to try. The formula here is just I. So I'll plug in 1, that's just 1, plug in 2, plug in 3. And again, you just plug in all the numbers, increasing by 1 each time until you plug in that top number and then you're done. Add up those numbers and you get 21. Here I would plug in 0, so it'd be 0 plus 1, and then it'd be 1 plus 1, and then it'd be 2 plus 1, and just keep going. And I plugged in 5 plus 1. So then I stop, add up all those numbers, and it also is 21. The last one I wanted one that was a little bit different. It's a j squared. Plug in j equals 3 first. So 3 squared, not starting at 1. So plug in 3, plug in 4, 5, 6, 7, and then add up those numbers. And I end up at 135. All right. So when we're talking about area today, we are going to be looking at the problem of finding areas of irregular shapes. So this says use 5 rectangles for an overestimation and an underestimation of the area under the region lying between the graph y equals 5 minus x squared, so that's this line. On the x-axis, it's this line. X equals 0. And x equals 2. So if you look at this shape, if we're asked to find the area of that, it is an irregular shape, which means there's no formula to figure that out. There's, we have formulas for areas of rectangles and circles, triangles, regular shapes that have rules for area, but if you have like a parabola as the top, there's not a way that we know right now to find that. So what we're going to do is estimate, and we're going to do that using rectangles. And the reason we pick rectangles is they're really simple, and the formula for area of a rectangle we know. It's base times height. So if we can find the base of this rectangle and the height, I could figure out the area for that rectangle number 1. And then I could do 2, and I could do 3, and I could do 4, and I could do 5. Once I have all those answers, I can add them up. And then I'd have an estimation. Now this would be an underestimation because I have a little bit of space at the top of each rectangle, so it wouldn't be exactly the shape that I'm looking for, but it would be an underestimation. Here, if you look at this one, the rectangles all go too tall, and so this would be the overestimation. So this is going to be the under, and this will be the over. Oops. Okay. Another name for something like this is called a right-hand estimation. And the reason it's called a right-hand estimation is if you look at this rectangle, this is the left side of the rectangle and this is the right side of the rectangle. If you go to the right-hand side and follow it all the way up till you get to the curve, then you go over, it's called a right-hand estimation because the right-hand side of the rectangle is dictating when the rectangle stops. Here, this would be called a left-hand. I meant AKA. And this is called a left-hand because if you look at the right and the left-hand side of the rectangle, you go to the left-hand side, you follow it up till you get to the curve, and then go straight over. So the left-hand side of each rectangle is dictating when you get to the curve, when you stop, and that's the height of your rectangle. So let's go ahead and estimate. We'll start with area of each rectangle. And we'll start with number 1. So it is going to be base times height. And the base, it looks like, because we went from 0 to 2, and we divided it equally into 5 rectangles, so each rectangle has the same base, and it's always going to be 2/5. So the base is 2/5. The height looks like it's just shorter than 5, and so we need to figure that out exactly. What we'll do is we'll take the right-hand side of the rectangle, which is 2/5. We'll plug that 2/5 into the equation. That's going to give us the height of the curve at that point, and that will be the height of the rectangle at that point. So f of 2/5, so 2/5 times, and then I'm just going to plug 2/5 in for x. So negative 2/5 squared plus 5, and it's 4.84. Sorry, 4.84. So the area for my first rectangle is 2/5 times 4.84, which is 1.936. I have to repeat that 4 more times. So it's base times height. The base is 2/5, and the height is going to be whatever I get when I plug in the right-hand side, which is 4/5. So I'm going to take negative 4/5 squared plus 5, and I get 4.36. So base times height, I get 1.744. Repeat for number 3. The right-hand side of the number 3 rectangle is 6/5. So base times height, I'm going to get my height by plugging in 6/5. And it's 3.56 times 2/5. Fourth, base times height. My fourth rectangle, the right-hand side is 8/5, so I'm going to plug in 8/5. And my height is 2.44 times 2/5. And then my last one, rectangle 5. Base times height, base is 2/5, the right-hand side is 2, so I'm going to plug in 2. And I got a height of 1. All right, so I got 5 rectangle areas, and I'm going to add them all up. So 1.936 plus 1.744 plus 1.424 plus 0.976 plus 0.4. So the total is 6.48. Now this was a area estimation. It was a little bit lower than the real area that I'm looking for, but that was my best underestimation using rectangles.